In this quick tutorial, I'll show you two examples on how to identify conic sections without actually rotating the axes. A non-degenerate conic section of the form shown on your screen can be identified as a parabola, an ellipse or a circle, or a hyperbola. Can be determined by first listing what your A, B, and C leading coefficients are. And based on these calculations, you can determine which one it is. That being said, in our question, we have to identify the graph of these two equations. So let's go ahead and identify what A, B, and C are. A represents the leading coefficient of x squared. For us, that's 3. So I'll say A, capital A is 3. Let's find out what B is. B is the leading coefficient of the factor xy. In our case, that's negative 2 times the square root of 3. And C is the leading coefficient of y squared. In our case, that's 1. So let's go ahead and substitute these values into this formula. And if you're familiar with the quadratic formula, this part is called the discriminant. So let's substitute that into the discriminant. We have negative 2 times the square root of 3 raised to the power of 2 minus 4 AC. 3 times 1. Now let's go ahead and find out what this is equal to using our calculator. We have bracket negative 2 square root of 3. That's being raised to the power of 2 minus 4 times 3 times 1, that's 12. And we end up with 0. So the answer to this discriminant is 0, and therefore this should give you a parabola. Let's go ahead and try B. We have 2x squared plus the square root of 3xy plus y squared minus 2. Identifying our A, we have 2. C is 1. That's the leading coefficient of y squared. And B is the square root of 3. Substituting this into our formula, square root of 3 raised to the power of 2 minus 4 times 2 times 1. Using our calculator, once again, I'll just erase this part. And 4 times 2 is 8. We end up with a negative 5. And negative 5 is less than 0, so this is either an ellipse or a circle. And from our previous video, we learned that when you graph this, you should get an ellipse. And there you have it. That is how to identify a conic section without having to rotate the axes.